Problem on work energy method. So two blocks are connected by inextensible wires as shown in figure. Find by how much distance block 400 Newton will move in increasing its velocity to 5 meter per second from 2 meter per second. Assume pulleys are frictionless and weightless. Okay. So what is the given data? So initial velocity is given u equal to 2 meter per second. Final velocity is given v equal to 5 meter per second. And finally have to calculate the distance moved by the block s. So this is the given figure. Here the weight is 400 Newton. Here the weight is 600 Newton. So which is the greater value? The 600 Newton is the greater value. Okay. The direction of motion is towards 600 Newtons. The 600 Newton block moving downwards. The 400 Newton block moving upwards. The 400 Newton block is having only one string. Okay. The 600 Newton block is having two strings. For suppose the 400 Newton block moves x distance. Here the x distance is shared by the two strings. Finally the 600 Newton block will move x by 2 distance. So here x distance equal to shared by the two strings x by 2 plus x by 2, nothing but x. Okay. The 400 Newton block move s distance. The 600 Newton block will move s by 2 distance. Here initial velocity is u. Here initial velocity is u by 2. Here final velocity is v. Here final velocity is v by 2. Suppose the block 400 Newton moves x distance. The block 600 Newton will move x by 2 distance. So block 400 Newton and block 600 Newton. Initial velocity is u. Initial velocity is u by 2. Final velocity is v. Final velocity is v by 2. Distance moved is s. Distance moved is s by 2. Now FBD of block 400 Newton. So this is the given figure. The 400 Newton weight acting downwards. The tension is acting always away from the block. Okay, the tension is acting upwards. The weight of the block 400 Newton is acting downwards. The tension of the string is acting upwards. The 400 Newton block moving upwards. Okay, so the direction of motion towards t. So finally the resultant force is acting towards the direction of motion. So what is the force in direction of motion? T is the force in direction of motion, so it is positive. Okay. So what is the force opposite to the direction of motion? 400 Newton is the opposite to the direction of motion, so it is negative. So finally resultant force F equal to T minus 400. Now applying work energy method, F into S equal to W by 2Z into V square minus U square. So F equal to T minus 400. Okay, S is equal to W equal to 400, G is 9.81. So V is 5, U is 2. So now multiplying with S, Ts minus 400S is equal to 428.13. Okay, this one is the equation number 1. Now FBD of block 600 Newton. Here the 600 Newton block moving downwards. So here this pulley is having two strings. Okay, in this string the tension is T. So on the string the tension also T. Okay, so finally the tension in this pulley is 2T. So tension is acting always away from the block. So tension is acting upwards, the weight acting downwards. Consider equilibrium of the block. So what is the direction of motion? Direction of motion is downwards. So what is the force in direction of motion? The 600 Newton is the force in direction of motion. So it is positive. Okay, what is the force opposite to the direction of motion? 2T. Okay, so finally resultant force F equal to 600 minus 2T. So now applying work energy method, F into S equal to W by 2Z into V square minus U square. So F equal to 600 minus 2T, S equal to S by 2. So what is W? 600, G is 9.81. So V is V by 2, U is U by 2. So now multiplying with S by 2, 300S minus TS equal to 191.125. So minus TS plus 300S is equal to 191.125. This one is the equation number 2. So by solving equation 1 and equation 2, comma, we get minus TS plus 300S equal to 191.125. By solving these two equations, for block 400 Newton, the tension in the string T equal to 472.69 Newton and the distance moved of the block S equal to 5.89 meters. So for block 600 Newton, T equal to T by 2. So it is 236.345 Newtons and distance S equal to S by 2 is equal to 2.945 meters.